Hi guys, welcome to my channel at _1 minute math. I'm your host, Teacher Victor. In this channel, I'll be taking you through series of solutions to various mathematical problems ranging from one topic to another. In this session, we'll be starting with the topic circle geometry, otherwise known as circle theorem. And the first theorem we'll be proving is the one that says that the angle subtended by an arc of a circle at the center is twice any angle that it subtends at the circumference. A proper diagram to illustrate this proof is AOC, the angle at the center of this circle, is twice the one that we see at any point on the circumference. Of course, we know what the circumference is, right? The circumference is the edge or the line that forms the circle. So the theorem is saying that any angle that is formed at the center of the circle is twice the one that is formed at the circumference of the circle, so long that both of these angles are sitting on the same chord, that is on the same segment. Of course, this line forms a chord AC. This angle at the center here is resting on this chord, and the one at the circumference is also on it. So because they share a common segment, or they are sitting on the same chord, the angle at center is times 2 the one at circumference. Let us see how we prove this. Come with me as we prove together. So the first thing we want to do in proving this theorem is to make a construction. In this way, we are dividing this angle at the center from the circumference into two parts, just like what you are seeing on the screen right now. Now, taking a look at what we have on your screen right now, you can see that at the center here, the line that is drawn from the center of the circle to the circumference is referred to as what? Radius. It means that this line OB is a radius. Also, OA is also a radius. And because all radii are equal, we can put a symbol here to show equality between these two lines, so that we can say that OA is equal to what? OB. And don't forget to always add your reasons. Our reason for saying this is that what? They are both radii, because they are all drawn from the center of the circle to the circumference. Remember, a radius is any line drawn from the center of the circle to any point on the circumference. So since OA, this line, and OB, they are both radii, then we can say that they are what? Equal. Hence, we got this first statement. Now, because we have made these two lines equal according to the fact that they are both radii, it brings about this triangle we have here called isosceles triangle, just like what you are seeing on your screen right now. Any triangle that has two of its sides equal. This theory has been proven from the theory of triangles, that any triangle that has two equal sides, they are called isosceles triangle. And there is something unique about this isosceles triangle. It is that the two sides that are equal, the two angles facing them are also what? Equal. So if this is the side facing this angle, and this side is facing this angle, because these two sides are equal, these two angles are also what? Equal. It means that whatever this angle is what this angle will not be. These two angles are actually called base angles of isosceles triangles. Now, since we've said this and this side are equal, it means that looking at this triangle, just like what you are seeing on your screen right now, this angle and this angle are equal. So whatever value we give to this angle is what this angle also what has. So let's call this angle x. That means this one becomes automatically what? X. It means that we can therefore say that angle x is equal to angle x. So just so that we can differentiate, we can call this one x1 and this one is what? X2. Are we together? So we can say x1 is therefore equal to x2. What is our reason for saying this? We said because they are what? Base angles of isosceles triangle. Now take note. Always write your reasons for every statement in full. It is just because I want to make this quick. That is why I'm shortening everything. So in your own case, when you are proving, always write it out in full. All right. So now we know that x1 is equal to x2 because these two angles, they are base angles of isosceles triangle. That being established, there is another law in triangle, another theorem in triangle that says that the sum of two interior opposite angles equals the exterior one. For example, if I have this triangle, just like the one you are seeing on the board right now, you will discover that if I call here x, which is just this one here, and this one a, for example, these two angles, when added together, it is always equal to this exterior one. It has been proven. We don't have to go through the details. All right, so that a plus x is equal to whatever we call this angle. Say, for example, d. That means a plus x equal to this external angle d. In like manner, if x1 adds to x2, we should get whatever value that is here. Since this diagram is just a replica of this one. So let's call this part a. It therefore means that x1 plus x2 is equal to what? A. And that is because of this theory we just stated, that the sum of interior opposite angle equals the exterior angle. So we say sum of interior opposite angles. You can close your bracket. All right. Now we've said this, we can further go to simplify this equation. Remember we said x1 is the same as x2. So this means that anywhere I see x2, I can substitute for what? X2 and put x1 there, since both are the same. So that in this case, I can have x1 plus, instead of me writing x2 again, remember x2 is also equal to x1, and that will be x1 equal to what? A. This statement is still the same as the previous one. Are we together? All right, so x1 plus x1 will give us, of course, 2x1 equal to what? A. And we call this equation 1. So we are done proving everything on this side. Now let's go to the other side of this diagram. So we remember that this line OB is a radius. Also, OC is also a radius. And because radii are equal in length, we can therefore say that OB equal to what? OC. Of course, our reason would be because they are what? Radii. In like manner, because this side and these sides are equal, it means whatever angle that is here or the one that is here will be equal as well. Why? Because this triangle reminds us of what? Isosceles triangle, just like the one we saw before when we were treating this other side of this diagram. So it means that our y1, if we decide to call this place y2 and here is y1, so that y1 will be equal to what? y2. That's because they are what? Base angles of isosceles triangle. Are we together? All right, let's keep on. All right. Also, from what we did before, we can also see that when we add y1 and y2 together, it gives us this external angle. From the diagram we have here, just a replica of the theorem we proved earlier. So that here being y1 and here is y2 should be equal to whatever we name this value of angle to be. And in this case, let's call it b, for instance. It means that y1 plus y2 is equal to what? B. And that is because of what? The theorem of triangle that says sum of interior opposite angles. All right. Just like what we did with this first part of the diagram, we can see that y1 is equal to y2. So we can substitute for our y2 anywhere we see it. So that in this case, we have y1 plus y1 equal to what? B. Of course, y1 plus y1 will be what? 2y1 equal to what? B. And let's call this equation 2. All right, the next thing we want to do is add equation 1 and equation 2 together so that we have something like this. 2x1 plus 2y1. So since 2x1 is equal to A and 2y1 is equal to B, if I add 2x1 to 2y1, it's like adding A to B. Are we together? 2x1 is equal to A. 2y1 is equal to what? B. So if I say 2x1 plus 2y1, it's as saying A plus B. So that in this case, I can factorize this and I will have 2 into bracket x1 plus y1, which is equal to A plus B. Now, let's go back to the diagram and see clearly. You will discover that x1 plus y1 forms the totality of this angle at the circumference. Remember, this is x1 and this is y1. So angle ABC is formed by addition of x1 and y1. So we can replace this with 2 into bracket A, B, C. And that will be equal to, looking again closely, we will see that angle A and angle B together forms the totality of angle AOC. So we can replace A plus B as AOC. And looking at this, we will see that we have successfully proven that the angle that an arc of a circle subtends at the center is twice that which it subtends at any point on the circumference. All right, guys, that is the end of this session. Don't forget to like, share, and subscribe so that when next I drop a video like this, you'll be the first to be notified. See you on the next one. Bye.